All right, ladies and gentlemen, hello and welcome back once again to the only coast-to-coast radio show that's all about the information economy. It's called Inside Analysis. I'm broadcasting from the Splunk conference here in Boston, and I'm so excited to have Hao Yang with me. He is in charge of all the AI at Splunk. That's kind of a big job. And so tell us just first of all, what is the nature of your job? What do you do day to day, and how do you align the power of AI with the customer needs and the internal needs that you have at Splunk?
Hello, everyone. So this is Hao Yan. So I have one of the best jobs at Splunk. I get to work on AI every day. So I lead a team of very talented data scientists, AI engineers, and product managers, really thinking about how we can actually use AI to power the Splunk portfolios to support our customers in the new agentic AI era.
Mhm. And agentic AI too. This is the latest flavor. When I think about agentic AI, I think multi-level automation because you have, of course, we all know automation, but this multi-level automation and the ability of an agent to be trained to take any number of actions depending upon the circumstances, that's the real kicker, right?
That's exactly right. So I think the holy grail of all these, AI is really to enable customers or the, human operators to find insights that they couldn't do today or couldn't do easily today, right? And then be able to investigate and find out what's happening, the root cause of a lot of things behind the scenes really, really rapidly, and be able to actually respond to those incidents or security, breaches really quickly, right? And then at the end of the day, it's about how do we enable people to do more? And in some cases, could mean that we can automate a lot of things so that people can basically step out of that whole cycles. But in many cases, AI is not perfect yet, right? So we still need human in the loop. So we are carefully designing that product experience to give you all kinds of flavors and then give also, customers the choices to determine how they're going to use AI.
Well, and the nice thing about these new AI, or even older AI models is that they can crunch through massive amounts of data very, very quickly, much more effectively than a human ever could. I mean, a human can have
Yeah.
gut instinct and can recognize patterns, but still the AI has the capacity to scan vast troves of data, find patterns, recognize patterns, and go, aha, this is a problem, and serve something up to the human to take action, right?
Yes, yes. So it's one is scale, right? And definitely, right? What these days we're talking about terabytes of data and even petabytes of data every day ingested into Splunk. Our largest customers do that every day, right? So just go through the vast amount of data to find anything in it, right? So we used to say, needles in the haystack. What's the analogy now? It's probably needle in the ocean. So we need to be able to handle that massive, ludicrous scale and be able to support all the models. The other one's complexity, right? So it's not just about the same thing repeating again and again. And now we have all different kinds of complexity in our systems. You have networks, you have cloud, you have, databases, and you have SaaS services, you have on-prem services, and all of that is integrated together, right? So any of these incidents could be actually triggered by the small things in elsewhere in your infrastructure, right? So how all these things working together, that level of correlation, that level of combinatorial effect, right? So I think that's going to be making that analysis harder and harder. That's why, we need more and more AI to help us unpack all these, complex relationships and be able to give you that insights.
Right. And I'm just guessing here that the partnership with Cisco is very compelling because, of course, Splunk has 20 odd years of deep expertise in understanding complex information systems, network, of course, tracers, logs, metrics, all these things. And Cisco has this vast treasure trove of machine data on the devices themselves.
Yeah.
So when that announcement first came out, I was like, wow, that makes a lot of sense.
Yes, yes.
And of course, G2 said we're not going to screw up Splunk, and he has really followed through on that. So that's got to be really exciting for a data scientist in your team to have this reservoir of information to use, right?
Yeah, that's exactly right. So we're thinking about that, what we call the better together effect in many different dimensions, right? One, as you pointed out, we have a lot of complementary kind of data. When you put the network data with security data, with the infrastructure data, with the application data, all of a sudden you have much more complete picture of what's going on in your IT infrastructure.
Right.
So that's one thing that is awesome. The second thing is that, as you said, we're putting all these things together to drive that machine data, AI for machine data, or, time series foundational models that really learn these nuances of what's happening in infrastructure, how different components work together, what is the impact of one thing on the other.
Right.
And so put them together,
Right.
then it really gives you that big picture.
Right. Well, the dependency trees, which can become incredibly complex. So having that reservoir of information comes in very handy because, and you have this whole history of incidents that you've tracked.
Mhm.
And so having all that at your disposal allows you to do the dependency assessments and it allows you to do predictive maintenance. I remember learning 20 odd years ago
Yeah.
from a guy in the airline industry who was the first to tell me about predictive maintenance.
Yeah.
And I was like, what he basically said is, look, we've analyzed enough of the data to know when this part starts to fail, that part's going to fail next. And then that part's going to fail. And so if you can beat that to the punch, you save a lot of time. And the other thing, I'm sure you'll appreciate this, is that it really changes the game for the worker because the worker, like it used to be the worker had to go through this whole long litany of things to check the screw, check the bolt, check this, check that, not knowing if there's any problem.
Yeah.
But with predictive maintenance, now you have a signal that says, hey, there's a problem.
Yeah.
So the morale is higher because you know you're focused on something meaningful. What do you think?
Yeah. So if you talk to any SREs or any security analysts, I think they will tell you that being able to foresee the patterns or foresee the problems in the future and prevent that from happening is going to be so critical because today in many of these cases, we're very much still in a reactive mode. When something bad happens, then all eyes is on, these small team that's put together in the war room and try to figure out what's happening. Every second counts, right? You get calls from your CEO and then, getting, updates every 5 minutes, right?
Right.
And then at that point, you just don't have enough sort of a tools that help you to figure out what's happening, right? So we're bringing a lot of AI and then using, AI assistant to help people really troubleshooting even faster. But if you think about that, shouldn't be the case to begin with, right? And if we actually through all these, AI predictions and forecastings to basically tells you that this part of the system looks really, shaky right now. And then if you don't take any action, something's
Right.
gonna about to happen, right?
Right.
And then it's almost similar to what you were talking about. It's level of complexity goes, probably through different order of magnitude, right?
Right.
Because in a manufacturing line, there's relatively small number of steps and well-defined, right? You can really have a playbook on what could go wrong, right? But in a modern infrastructure, just with, the hundreds of different systems that sit in place, you can't really write a playbook of what can go wrong, right? So it's really hard for you to have a predefined list of things you can check and then say what is going on, right? And then you have to be able to analyze the situations on the fly and then quickly make some assessment and then also dynamically come up with some sort of a response plans. I think that is where I think AI, especially with these large language models, large reasoning models, these new sort of frontier models for time series data, all putting together is going to be able to enable.
Right. And I love the news about the open source time series foundation model. That is really fantastic because time series is a very specific challenge to understand. You have events that occur in a certain period of time. Wherever you place those markers makes a big difference in terms of understanding what the impact is. Was this a cause? Was this an effect?
Yeah.
And to have a foundation model built, so tell us a bit about that because that's really interesting.
Yeah, we're super excited about that as well. So I think time series is just different kind of modality, right? So if you think about today's large language models, very much trained on human language, right? English, Japanese, Chinese, Germany, but all of that is speaking the human language. But machine doesn't speak that language, and machine speaks physics, right? Machine speaks some sort of, engineering sort of principles, and then how this different system going to come together, right? So there's a lot of causality effect. There is also a lot of these strong correlations, right? And then you kind of start to see different kind of patterns with different type of systems, right? For example, when you look at CPU utilization versus memory utilization versus network traffic, you see very different kinds of patterns. But nonetheless, within each category, there is its own sort of a physics of laws that's governing how things are working. And then there is also a well-defined set of patterns you might be expecting, right? Now, the challenge is that how do you have a model? Because today, people are looking at time series based, for example, anomaly detection, quite frequently, right? So a lot of the production systems have those things in place. But one of the challenges we are facing with today's technology is that everything has to be configured in advance, right? So you basically, for every type of things, for every devices, for every kind of metrics, you have to train some sort of a model that's customized for that.
Mhm.
So therefore, the amount of efforts you need to set up that capability, and more importantly, as things evolve, the amount of efforts to keep things up to date is just prohibitively expensive, right? So
Interesting.
you can always have system that was set up 6 months ago, but it's not quite working now, right? And then people just never get the chance or the time to actually refresh it, right? So
Right.
there's a lot of challenges, and then the foundational model for time series is really coming to say we can actually do a lot of these things with almost zero configurations, because these foundational model has this zero shot capabilities for a lot of this analysis. And the reason is because it was trained on massive amount of data, and then it has, basically a breadth of knowledge about different kinds of, we're looking at. And then also we have this ability to do multi-scale analysis to break down a large, window into smaller windows and look at things in a more composable manners, right? So
Mhm.
then you can basically have some unit of thinking, unit of things that you're looking at, then you start to compose together. Like if you think about that time series as a graph, then you start to break them down and break into sort of a pieces and then compose them together. So that's how
That's
we are thinking about that foundation model.
Yeah, well, and also what I find fascinating, and to your point about this zero shot capability, is that these foundation models, ChatGPT, Gemini, Anthropic, Claude, you have all these different versions out there. They have, to your point, been trained on tremendous amounts of information.
Yeah.
And it's what's interesting is you can play around with them and discover all kinds of things. Now, there are still
Yep.
hallucinations, so we're still working on that, obviously. That's
Yeah.
something to be concerned about. But how much does that change the game in terms of your teams being able to do some ad hoc analysis and just ask open-ended natural language questions to kind of
Yeah.
find their way to an answer?
Yeah. So I think you need really both human language and machine language to solve that problem end to end, right?
Mhm.
Because, for example, when as a human, we think about how, for example, some of these infrastructure is going to affect my sales performance, right? So
Mhm.
if you think about that is the level of, thinking that human have, right? But
Mhm.
in order to answer that question, you have to understand the intent, like what this person is trying to do. And then that maps to some sort of embedding space, and you break them down into, steps that you need to look at. For example, you need to know where you're going to be looking at for your sales performance, where you're going to be looking at for your server performance, right? And that's where, machine data comes in, because a
Mhm.
lot of that is not really in some sort of a box or anything. It's basically, time series keep coming in, right?
Right.
So you need to be able to say, how do I understand that time series is coming and what is telling me? Like, is it normal? It is running hot. It is going to show some signs of problems in the next 4 hours, right? So you need to be able to analyze those, time series and get those insights.
Mhm.
And then you need to be able to map that insight back to some of this human language so that you can basically provide the answer in the end.
That's very interesting. That's a very, very good point. And so here's another interesting question for you. There's new hardware coming on the market all the time. Of course, Cisco has its own
Yeah,
portfolio of products, and there are lots and lots of other companies building things.
sure.
How much of your team's effort is focused on understanding new hardware that's coming out, what its signatures look like, what its data looks like,
Yeah,
and how that fits into the bigger picture?
yeah. So Splunk is platform agnostic, right?
Hmm.
So our customers actually ingest all kinds of data into Splunk, all the hardwares you can possibly imagine, and then all the software and services that you can imagine, right? All of that is coming into Splunk, right? So we don't necessarily just work with a specific vendor to try to understand the new hardware is coming, right? So
Hmm.
I think the approach we're taking is really data driven, right? So we can actually observe those in the data streams. We can have ways to automatically extract those signals and be able to refresh the models to incorporate those kind of new hardwares.
That's very interesting.
Yeah.
Well, you have such a treasure trove of information because you've
Yeah.
had so many clients for so many years now in so many different environments. And that's the reality on the ground for really any enterprise, right? Is that every enterprise is unique.
Yeah.
Even if they're mostly an Azure shop or mostly a GCP shop,
Yeah.
nonetheless, you've got on-prem, you've got network issues, you have all kinds of different things in the environment.
Mhm.
So Splunk benefits from all those different pieces of data, right?
That's right. So we actually wanted to provide the most comprehensive sort of models for our customers, but also recognize, as you said, every customer has some unique environment, unique constraints. And that's why on top of that model that we provide, we also wanted to give our customer that ability to customize the model even further for their own specific data environment, right? So we have product that has been in the market for many years called Machine Learning Toolkit, and we're now sort of expanding that into AI Toolkit, because in the past, Machine Learning Toolkit is mostly allow people to train, machine learning models like regressions, classifications, those type of things, right? So now we want them to actually use the same kind of, environment and toolkit to be able to fine tune models for their own data.
That's very interesting. And one of the knocks on AI over the years has been that it's hard to get into production. So you might design a model, it's hard to get into production. But Splunk, you have a lot of experience doing that.
Yes,
Right?
exactly.
So you know what the endpoints should be. There's some score that's delivered. You manage and monitor that over time to tell when it maybe is not as effective as it was, because the environment changes. I mean, think about COVID and how COVID changed human behavioral patterns all over the world. Right. And so all these models that have been built had to be kind of thrown out the window and you started over. Right. But it's like, because you have so much experience doing that, you're a good partner in helping companies not only design the right model or choose the right model, but deploy it, manage it, and then run it. Right.
Yeah, you said it well, right? So because at the end of the day, I don't think there is a single model that works for everyone, right? So I think it's really about the methodology. It's about a good foundations and the ability to actually customize that for each individual customer. I think that's what matters in the end.
Well, and also we got about a minute and a half left here. And I heard some folks talking about this, which was very encouraging. You're going to have layers. You have a deterministic stack, for example, that runs your business. Then you have an AI layer, which is sifting through data, making decisions, and then feeding into the deterministic stack. And I think that in the future, you're going to have lots of different models and businesses doing different things: sales optimization, marketing optimization, managing and monitoring accounting, for example. There's an interesting company doing that. So it's like all these models have different purposes. The key is to deploy them in their environment and make sure that you have appropriate guardrails around them so that they do what they're supposed to do and they don't bother other stuff, right?
Yeah. So I think there will be in the future this multi-agent world where you have a lot of specialized agents, and they could be running some, general purpose models, but they could be powered by specially built models. And then the key is, to your point, one is that you have this unified sort of a data layer that basically there is a single source of truth. You have a way to manage your exploding sort of a data environment, right? So that's where Splunk comes in. And the other one is that you have to think about in that world how these agents work together with each other, right? So we're heavily investing in MCP, and then we are launching Splunk's own MCP servers. The idea really is that all these different agents can interact with each other through an open standard like MCP, so that it can basically deliver that holistic value to customers.
I love it. Another MCP server. We need one, at least from Splunk. Folks, we're talking to Hao Yang of Splunk. Look him up on LinkedIn. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, your host, Eric Kavanagh, now talking to Josh Rubin of Fiddler AI. Of course, I'm back now from the Splunk conference where we talked all about observability in the context of security, of course, but I also asked about observability in the realm of large language models. And can these things be instrumented? Can a company like Splunk, for example, give me visibility into when a large language model might be hallucinating? It's a very good question. There are a number of different ways that companies are approaching this. There's a company, Vectaro, we've done some work with. They talk about guardian agents, which I think is a very interesting concept, where basically they have a separate instance of a model that goes and checks on the work of the first model. It says, okay, does this look good? That's quality assurance, basically. That's what they're doing. It's a guardrail. It's one way of doing it. Now, that does not ensure success. It just gives you another opinion. It's like talking to a doctor, getting a second opinion on something. They could both be wrong. It's not impossible to have that happen. But someone who knows a lot about all that is Josh Rubin of Fiddler AI. So, Josh, welcome back to Inside Analysis. And tell us what's your take on observability for large language models?
Well, yeah, thanks for having me, Eric. I think that the space of large language models applications is sort of expanding very rapidly, right? People talk about, when we speak with customers, we've moved things that people refer to as RAG, retrieval augmented generation, which is basically a chatbot connected to a knowledge base. And everyone we're hearing from now is building applications that people refer to as agentic. So it's, how do you give the model some agency, let it use its reasoning ability, let it use tools, call into databases, call into tools, call into other language model components. So you can imagine this sort of like constellation of different smart components all interacting with each other, you know, potentially sort of solving a problem with routing that is not, you know, entirely deterministic. The model may be choosing its own solution path. And so, you know, the observability question becomes very interesting. What you want to think about doing is starting to instrument all of these individual components with its own kind of bespoke metrics of quality. So you have some ability to identify when there are failure modes and some ability to identify when overall quality is degrading over time. So I guess from an observability perspective, two things that are really interesting. One is kind of root cause analysis, like what are common failure modes for the model? The other is performance over time. How do you look at this thing holistically as a time series, track metrics that are appropriate for that component or that application, and then get some sort of alert or notification that lets you know when it's time to, you know, do something to work on model quality.
No, that's interesting. Now, so I think, are you alluding to MCP here, Model Context Protocol, and the fact that everyone and their grandmother now has an MCP server? I've never seen anything take off as fast as MCP. I mean, everyone has an MCP server now. You want to talk
Yeah,
about that for a second?
sure. Yeah. You know, as I warn others around Fiddler, you know, I think you have to be mindful that we're really quite deep in kind of a hype fog right now. You know, as you know, things week to week are changing so rapidly, and what seems like it's hot or what seems like a new direction is changing quickly. Certainly, MCP is interesting, right? MCP gives you ability to take like an application like a, you know, um, and you know, Anthropic's like Claude desktop tool or some other you know, large language model hosted in an application and connect it to other data sources or other tools. And you know, people talk about it like being a USB. You know, it's basically a combination of offering a model a protocol for retrieving information or taking an action, and also providing the language model with some information about what those tools do, right? There's a component of that is prompting the model with like, here is the list of tools that you have access to. You call them this way. Here's what they're for. You know, use them under these conditions, right? So MCP provides that mechanism. But I would, you know, I think a criticism of MCP is it tends to introduce a lot of latency, a lot of non-determinism into systems. And you know, it's certainly something that's a technology that's worthy of being excited about. It makes a lot of things possible. It's not the magic glue that sticks together, you know, complex agentic applications, particularly when you're thinking about things that need to be reliable at sort of enterprise scale. There are challenges with, you know, sort of predictability. As I mentioned, the latency issue is also a big one. When you're taking hops between language models, allowing language models to select how they connect to data and then returning data through that mechanism, sometimes a better solution are, you know, sort of standard software endpoints. You know, if you know what your model is going to need and what's going to be doing, you might not need that flexibility to allow the model to explore tool use on its own. So I would say, you know, hugely valuable, but not a kind of one-stop solution for every situation. There are lots of scenarios where you would be much better served to, you know, sort of stitch these pieces together using more kind of traditional software endpoints and orchestrating workflows in a more deterministic way.
Yeah, that's a really, really good point that you just made. And this has been on my mind for quite some time as well, which is what is the layered approach that you're taking? What are the endpoints? Where are you plugging in the results from the large language model? These are all really, really important things to consider. And I think you're going to have these layered architectures where you have something deterministic and then something stochastic and something deterministic and stochastic. And that deterministic stuff, that's going to be probably your guardrails, even though the example I just gave of Vectara, it's really a probabilistic guardrail. But it is going to depend upon the particular use case, and it gets into some pretty fine-tuned details, right, of your architecture and how you design the system itself around the model, right?
Yeah, I think, you know, one analogy that I really like about the difference between building applications with, you know, large language models and building applications with traditional software is, you know, traditional software does nothing when you first open an empty file, and then you start adding functionality to it. And in a way, generative AI, it's a little bit like it can do anything before you start to constrain it. And then you gradually carve down its behavior to the thing that's specifically what you want. It's a little bit more like, the way a liquid fills a container. And that's a really different mindset. It's more like sculpting a thing. It's a kind of subtractive process. A lot of what makes, individuals or organizations successful, with generative applications is really giving it prompts that direct its function and its output. The magical thinking about like, we'll just give a user interface and then we'll put a language model and give it a bunch of connectors and then it's going to solve our business problem or it's going to be our application. That's sort of a recipe for kind of a mess, something unpredictable, for something slow, for something that's just not a reliable. That's kind of the vibe codey direction, right? Successful teams are constraining the behavior of the language models quite precisely, and finding ways to measure how well they perform in those applications. So, understand what it's for, direct it in a focused way towards that, and then figure out how to measure it and iterate on it to improve it over time. That seems to be the success formula.
Well, that measurement side, that's pretty hard. I mean, I guess, you look at the database world, of course, and we had the TPC benchmarks for years and years and years. And now you got MLPerf, which is kind of the TPC version for machine learning models, basically. But it's very, very complex. I mean, TPC was always a bit of a dubious entity, in my opinion, because you can overfit to pass the test, basically. And you don't want to do that, obviously. So how do organizations go about designing testing parameters to do what you're talking about, to gauge the efficacy and then know, like, what does that even look like?
Yeah, so we look at the problem from kind of two directions. So we have a kind of observability product that provides kind of sort of offline analytics, and it attempts to instrument the components of an agentic system with a variety of configurable metrics. So some of those are sort of out of the box things that cover standard usage patterns. So it could be is this in the standard kind of RAG scenario, like something like hallucination detection, you can ask a faithfulness question like, is this response from this LLM application, is that faithful to some context that was provided to the model to summarize or to extract, right? And in some scenarios, you want to build some sort of a bespoke metric, right? So when you're doing something novel, what defines performance for that particular component or for that particular application is really a sort of it depends on the function of the thing, right? And so the way we think of it is we have a combination of fine-tuned kind of proprietary models that do some of the common stuff. We can also do things like use LLM as a judge, where basically you can prompt a model to evaluate inputs and outputs of another model for a specific purpose. And all of this in the interest of sort of building the scaffolding that provides you a series of metrics that are worth tracking over time. And one thing I'll add that I think is really exciting is, increasingly we're looking at mechanisms for basically anticipating quality questions based on traffic that our users have published into the observability platform. So, if you can feed a language model with, a smart language model with enough data that's streaming into the platform, it can try to identify detail about like, what is this component trying to do? What might be metrics of success? And so what we're starting to see is that there are a lot of scenarios where we can basically meta prompt. We can say, smart model, go make some proposals to the user about how their system or their component should be evaluated. And then it can produce specifications that are handed off to a smaller language model to go and measure those over time. And that seems like a really low friction way to basically allow our users to hit the ground running. Like all they have to do is start streaming traffic into our platform. And then, a lot of this instrumentation sort of becomes proactive
Hmm.
from our side.
That's very interesting. So how does your observability platform work? We've got about 3.5 minutes in this segment.
Sure.
Where are you pulling data from? How does that pulling take place? What does it look like on the inside where you're actually persisting things?
Yeah, so we've really reworked a lot of our platform. So for your listeners who aren't haven't followed the whole story of Fiddler AI and maybe haven't heard the last time we talked, we come from predictive AI roots, right? We did a lot of explainability. We did monitoring for ML and predictive AI, um, and we historically had used, define a model schema, push traffic into our platform that conforms to that schema. We've totally rethought that going into the generative AI product, which I think is pretty exciting. Basically, the entry point now for this Gen AI product is, instrument your AI application at code level. A lot of frameworks already provide this. So OpenTelemetry is sort of has become the common communication mode between generative applications. And we see this now kind of built into a lot of frameworks. It's also very easy to instrument if you're building something custom. But basically, it produces hierarchical traces that capture inputs and outputs of various components, when they were called, what they did. And then we can reconstruct that information on our side. So imagine your application running with some fairly modest hooks for where telemetry is produced inside of the code. And then that just streams into our platform. We run aggregations on that data and we log it. We're using ClickHouse under the hood as a database. It's a high performance columnar store that's very parallelizable. But that allows users with interrogate individual traces. So if you wanted to follow a particular example or instance, like a user session talking to a chatbot, you can approach the data that way. And then the other thing that we can do is aggregate data across many sessions and provide statistical information over time about those performance metrics that you have chosen to instrument your components with. So it's a combination of sort of instance level tracing and sort of aggregate information that provides overall performance charts, tells you if something's changing in the world, and can fire off alerts to let you know if it looks like something is going wrong. Like maybe your users are starting to ask your chatbot for a piece of information that's not in your database, and the chatbot is getting bad, empty responses back, and that can trigger hallucinations, right? You're seeing hallucinations, but the problem is a database retrieval problem where there's missing information. So we'd like for our users to be able to identify that quickly. We would fire an alert on something like that, and then attract the user to, here is a class of queries where your database doesn't have sufficient information to answer. And that's generally a quick fix.
Yeah, that's actually a very, very interesting point, because what you're doing is you're giving observability into the database retrieval components of the workflow, as opposed to just trying to determine, okay, is this true or not true based upon the output. You're going one level deeper and saying, okay, we were not getting values back from the database for this period of time. That's a red flag. Let's throw that up there. I mean, that's what observability is all about, right? Well, folks, don't touch that dial. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to Josh Rubin of Fiddler AI. And Josh, there are so many ways to skin the cat, as they say these days. You suggested that, of course, RAG models are very popular these days. But the agentic side, this is very interesting. Instead of a traditional RAG model, you can have this agentic approach where you've built agents that go and kind of do their own little thing. And that can include any number of tasks, because at the end of the day, if you give the model enough relevant context, it's going to do a good job. And I've talked to a bunch of different people who say the same thing, which is the more specificity you can give, the better, without going too far. Like there is such a thing as going too far, and then it just kind of doesn't know what to do and falls apart. But is that basically what you're seeing? Is that this agentic approach is solving problems by allowing folks to pull in the data they need from their databases, from their traditional deterministic systems, to provide anchors for the stochastic results that you get from the large language models?
I'd say that's the vision. I think that, and one thing that we see at Fiddler in our sales cycles is, if you look across the organizations who are our customers and the organizations that we talk to who are, trying to buy a product for observability, I think, again, to the question of sort of appropriately like sort of scoping and defining the function of the thing that you want, everybody's buying sort of products for what the future looks like. They're sort of anticipating full-blown agentic AI, autonomy, AGI maybe a year from now. And so at least on the enterprise sales cycle, there's a lot of buying for capabilities that maybe, for applications that they anticipate having a year out from now, using technologies they heard of a week ago. And so, I think what you described is the right vision. I think what that turns into as the hype fog kind of clears, it may be that the design patterns that are reliable and, sort of low risk are a little bit more modest than that vision. Or so agree, and a caution, I guess, to your listeners that everybody is extrapolating out into what this looks like a year or two from now, and the data we're working from is changing in real time. But I think the strategy of thinking about generative AI applications as a constellation of components, some of them tools, some databases, some language models, maybe multiple language models who have different sets of tools. I think if you think about those systems as those things being the kind of core primitives, and you think about the task of how you measure the performance of those things or track their behavior or improve them over time, with that picture in mind, I think it's hard to go wrong, depending on where the future goes, right? So some combination of those pieces will be the right answer.
Well, and who was I talking to who made an excellent point? They said that the number one rule right now for being successful with AI is experimentation, is playing around with these things and having a team focused on trying things out and seeing how they work. And just, I mean, and that takes effort. It takes time. It takes a process. It takes discipline to do that. But the idea is that, look, we really are at the beginning of this very interesting, compelling, and unwieldy time. And it's going to be very hard to nail down what are the use cases for this sort of technology. So that experimentation is really important to get the right muscles working in the brains, to understand what the protocols are going to be, to figure out where those guardrails are going to be, because I think it's going to be really important for organizations to think through that layered approach. What is the workflow? Where are we hitting these models? What are we pulling back? To your point, how are you measuring the efficacy of that? How are you measuring the accuracy of that? These are all really important things to sort out before you start thinking about what you're going to do with it 1 year from now, right?
Yeah, I think crawl, walk, run is the right approach. This is different than developing traditional software applications where the engineering aspects are largely well known, and you can define a large scale product from a high level, allocate resources for it, and sort of expect it to work at a certain level of quality. I think the conversation between, at least in an enterprise setting, between budget holders and practitioners needs to be closer and more iterative. And people need to be given the opportunity to build something small that works reliably before trying to go straight to, building a bridge or a skyscraper.
Well, and are you seeing that the use cases are still largely internally focused? In other words, as a co-pilot or an assistant kind of thing, as opposed to externally focused to customers, prospects, partners, that kind of thing?
I see more internal because I think partially because the risk is lower, right?
Right.
I think all of us are feeling a little bit of chatbot fatigue also. And so when you can instrument an internal, and again, my perspective is coming from the kind of enterprise user or enterprise application, but at least for those orgs, there's a lot to be gained by building internal applications that streamline human work, whether that's you know um, lead gen in a marketing or sales team, or customer success where a human being might be supplemented by an answer that comes from a language model first, where they have the option to edit it and can supplement if they want, but
Yeah.
don't have to craft the whole thing from scratch.
Right.
There's just lots of these internal processes where there's a lot of efficiency gains and gains in human performance, keeping
Right.
humans on the rails. The best of what do you call it? Human in the loop AI, I guess used to say.
That's an excellent point, and I think it bears repeating that, what you're saying is, folks, look, you can leverage these technologies in all kinds of different ways and recognize when you're just expediting time to value, whether it's by combing through tedious detail to give the signal over the noise, or just greasing the tracks to getting some report written, some document published. I mean, who was I talking to? A lady who said their whole invoicing process, they've now expedited statements of work, invoices, purchase orders, things of that nature, where it's pretty formulaic and it's just basically usually a lot of time to kind of bang through it. That's a great use case because now you're just checking for accuracy instead of filling out all the darn forms yourself, right? But right there, you just saved a lot of time and you boosted morale. What do you think?
I love it. I like those use cases. I do think that we do over time we have started seeing the customer facing use cases also, and there it's just that much more critical to have a sort of instrumentation and performance tracking mechanism in place, because there's just a litany of these like reputational harms and financial harms that have occurred to
Sure.
companies for doing something stupid with a kind of hasty rollout of something that wasn't prepared for prime time. The better, I mean, instrumentation helps you iterate quickly and solve problems fast, but it also forces you to think through the structure of your thing and build it in a logical way that's sort of well constrained and well scoped. So it has a kind of dual benefit. And so before you go customer facing, it really is important to sort of address some of these observability issues.
Yeah, that's a good point. And we got about 2 minutes left here. So
Mhm.
what are you working on now? What's the next bit of functionality you're looking to roll out?
Yeah, so I think the launch of our sort of the kind of our agentic monitoring product is in sort of an early preview state right now. So we're sort of in the polishing stages of that. I think it's exciting. It does a lot of the things that I always wished Fiddler had done in its prior iterations. It's lower burden to get data in. It's uh, elegant and sort of immediately useful without a lot of drilling down into complex dashboards. The cognitive burden on the user, I think, is lower than it's ever been for how to use it and what it's for. I think some of these issues around configuring, sort of bespoke prompts for, language model evaluation when you're trying to instrument components with, sort of appropriate metrics. The combination of making that very low barrier to entry for humans who want to customize that, and also the possibility of like meta prompting those things from a smart model that's doing traffic analysis. That stuff makes me really excited because that just allows, I mean, the lower you can make the barrier of entry to a user who wants to, I mean, instrumentation is traditionally burdensome.
Right.
And if you can really lower that barrier, if you can make it
That's
really
interesting.
easy to configure something and get something useful out, it just, the user experience and the value is just really amplified. And so that's exciting to me.
Yeah, that's good stuff. And I mean, you bring up an excellent point. Instrumentation is what leads to observability. So how you do that is going to have a big impact on how well it all works out and what you're able to glean from that. Well, folks, look this gentleman up online, Josh Rubin, Rubin of Fiddler AI. They're doing very interesting stuff. We'll talk to you next time. You've been listening to Inside Analysis.